Good afternoon, everybody, and good morning to those who are where you are located somewhere that it's morning. My name is Lee Ball. I'm the Chief Sustainability Officer here at Appalachian State University. I want to welcome you to the Appalachian Energy Summit webinar series. So today's webinar is titled Revolutionizing Public Transit Battery Electric Buses. And today we have Lauren Cochran Scoville, who is the Senior Director of Sales at Southwest US Proterra. And Lauren has a tremendous amount of experience working in the public transit sector and working with a lot of innovative strategies related to all things sustainable transportation. And James Keel is the Director of Greenlink in Greenville, South Carolina, and he runs the transit system in that community. Next slide, please. So Lauren, are you there?
The host is asking to unmute me. Can y'all hear me now?
Yeah, hey Lauren, how you doing?
Hey, good afternoon. I'm doing really well, thanks.
Thank you for joining us today. So
happy to be here.
Yeah, we're very excited that you're here, and you have so much experience in this realm, and Proterra's lucky to have you with all of your background with all things transportation, and we're really excited to hear what you have to say today. So take it away, please.
Awesome, thanks Lee, and thanks to everyone for joining this morning or afternoon. Depending on where you're joining from. I'm really excited to be here with you guys and look forward to the conversation. So I'm the Senior Director of Sales for Proterra. Next slide, please. We are really the market leader in battery electric buses in North America. All we make are battery electric buses, the batteries that go in our buses, and chargers. So our mission is to deliver basically the best, highest performing platform that we can. We are headquartered in Burlingame, which is essentially San Francisco, and we have offices and manufacturing facilities on the West Coast and on the East Coast. So West Coast in the City of Industry, just outside of Los Angeles, East Coast in Greenville, South Carolina. If you could go back to the previous slide, please. So many of our transit agency partners use federal funding to buy their buses. And so we're a US company, but we also have 75% domestic content on our vehicle, which is often a requirement of using federal funding to purchase buses. Over 500 employees strong with really strong transportation expertise. Before I joined Proterra, I was with Houston Metro. My boss is retired from the Chicago Transit Authority. We also have a lot of automotive expertise too. A lot of people on our team from Tesla. And in fact, that's one of the reasons we relocated our headquarters, which used to be in Greenville, to Silicon Valley, so we could leverage the talent there. We have more than 125 customers now, more than 1,000 vehicles sold, 13 million miles, zero emission miles of service, and 60 million pounds of CO2 emissions avoided. We are a privately held company. We're backed by two of the US's largest utilities, Edison International and Constellation Energy. And utilities for us are like gas stations for a vehicle with an internal combustion engine. So the fact that those are two of our largest investors, we think is an exciting partnership, and also really speaks about where we're headed and the future of certainly public transportation. Next slide. So here's a couple of pictures of our manufacturing facilities at our headquarters. That's actually where we design out and manufacture our batteries. So you guys may know that we put our batteries in other heavy duty platforms that are not buses or not transit buses. So we put our batteries in school buses, in a low floor cutaway vehicle through a partnership with Optimal. and a delivery truck. So our batteries are modular and stackable, and so we're able to expand beyond the transit industry and help other vehicle platform OEMs electrify their platforms. Next slide, please. So here's where we're headed as an industry. The public transportation industry is rapidly shifting to electric buses. I was actually part of the Proterra's first deployment, which was 10 years ago 2 weeks, 10 years ago, 2 weeks ago, our first 3 buses went into service. And those buses were $1.2 million each. That is not sustainable, but making the first 3 of anything is really expensive. And so with economies of scale, across our industry and others, we've seen the cost of buses come down, and that's really helped to drive electrification. The other 2 main drivers are improvements in range from 10 years ago to today, and also charging standardization. So we went from a proprietary Proterra developed system to universal methods for charging our buses. So that's also helped drive adoption. So today, about 17% of new bus purchases are battery electric, and the cost of our vehicle has come down to about half of what it was 10 years ago. Next slide, please. And we predict that by 2025, 50% of new bus purchases in North America will be battery electric. And if you think about what's happening on the electric car side, we all heard some exciting news come out of California this week about their ambitious goals. But right now, even in states like California, new car purchases are only about 5% electric. So to see 17% of new bus purchases electric and 50% in the next 4.5 years, there's just a crazy adoption happening, and it's happening quickly. And what's driving that is several states and communities have commitments to zero emission transportation. So in California, for example, they've committed to be 100% zero emission transit by 2040. It is a mandate. You already couldn't buy a diesel bus there, but now, you can't even buy a natural gas vehicle going forward. So we're excited to see these commitments, and that's really helping to push for electrification. Next slide. Here are our customers. I know this map is teeny tiny, but hopefully we have electric buses in communities where you're joining us from. As I mentioned, we have more than 125 customers now, over 1,000 buses sold. And I think what's important about this map is not really all of the communities we're in, either with transit, airports, or universities. It's that electric buses are not just in blue states. They're not just on the West Coast. They're everywhere. They're north, south, east, west, hot places, cold places, because reducing local air pollution is generally something that everyone can get behind, and everyone can get behind reducing operating costs. And so that's really what we're committing to helping our customers achieve. Next slide. So I wanted to just briefly touch on the total cost of ownership advantage. And really what this is, when you are a transit agency and you are a steward of taxpayer money, and you have to justify an investment in a battery electric vehicle like a bus, there's still a gap in the upfront purchase price. So a diesel, a hybrid, and a natural gas vehicle are still a little less expensive than an electric bus, even though the cost is coming down. So again, if you're a steward of the taxpayer dollar, why would you invest in something that's more expensive? Our customers have to justify that choice. And our company believes that something, we can't be sustainable as a business if we're just environmentally friendly. There has to be a financial proposition there. And so the total cost of ownership advantage really means that you can't just look at the upfront capital cost of an electric bus. You have to look at the life cycle cost of that vehicle. And so when you look, and we've got national averages shown here on the screen, When you look at the opportunity for savings in fuel, in maintenance, our bus has 30% fewer parts. It doesn't have an engine. You're not doing an oil change. There's an opportunity to save $433,000 versus diesel per bus over its 12-year life, and almost $400,000 versus natural gas. So while the bus may be more expensive up front from a capital cost perspective, there is a significant opportunity for operating savings over the life of the vehicle. And so that's a really important point to make, especially when people say, yeah, but your bus is more expensive. Yeah, it is up front, but in the long run, it ends up saving the agency money. Next slide, please. You may have seen last week that we announced our latest generation bus, the ZX5. So Z is zero emissions, X is maximum range, and 5, this is our 5th generation battery electric bus. We have delivered more battery electric buses than any other OEM in North America. And in fact, we've delivered almost half of all of the battery electric buses in North America. So excited to roll out this 5th generation product. Next slide. Just a little bit about the bus. It has the longest range of any battery electric bus on the market, and that's due to our battery technology and also the drivetrain. So we have an electrified axle. So we have a motor in each of the rear wheels. And we also have batteries that have the highest energy density on the market. When you combine that with a lighter weight vehicle, we have the longest range. We also have the fastest acceleration and best hill climb capability. And again, that's offered by, and thanks to our dual power drivetrain. This new bus is refined based on the last 10 years worth of experience. So really everything we've learned from our customers has been put into manufacturing this latest generation bus. And as always, it's a purpose-built vehicle. So we, as I mentioned when we started, only make battery electric buses. We built this bus from the ground up to be an electric vehicle. And that really, and I'm gonna talk about that in a few slides, but that really distinguishes us from other battery electric buses in the marketplace. Next slide. Just very quickly, some of the big changes between our last platform, which was the Catalyst, and the new ZX5. The first is a refined body. The second is this bus is built for scalability. So anticipating those additional battery electric buses deployed pretty rapidly over the next few years. And then finally, a smoother ride. Next slide, please. All right, so at Proterra, we say that we're different by design. And so I mentioned that a second ago, we have a purpose-built bus, but I wanna talk through what that really means. So we're gonna talk about first of all, the body of our vehicle and how that's different from other electric vehicle platforms, our flexible energy storage systems, our drivetrain options, and then finally, how you charge the buses. Next slide, please. Keeping an eye on time here. Okay, so we have a highly differentiated platform. First of all, we use a composite body. So most buses are steel or aluminum. Composite is basically carbon fiber and balsa wood. So it's very lightweight. We have the lightest weight vehicle on the market. So if you think about what that means in terms of an electric bus, reducing weight from the get-go is everything in terms of improving efficiency and the performance and the range of the vehicle. And then on the next slides, I'll talk a little bit more about our battery packs charging. Thank you for changing the slide. Go one forward. Perfect, yeah. Okay. One more, actually, stay right here. So the composite body, I mentioned that it is lighter weight, but it's also highly durable. It's non-corrosive, it's non-conductive, and it's rust resistant. And so you can really think about the body of the bus almost like a Yeti cooler. It's almost like indestructible. And so transit buses, because they operate in congested roadways, they do have a lot of lane changing maneuvers. There are a lot of other roadway users around. people run into buses. I don't know why that is, but they get in a lot of little accidents. People just don't see buses. They run into the back of them. So the ability to quickly repair the bus and have the energy in the event of an impact absorb over the body of the vehicle is really important in terms of, you know, quickly repairing that bus and getting it back into service for customers. The fact that it's non-conductive, since we deal with high voltage systems, that's also really important from a safety perspective. Next slide. Next slide too. Okay, so another, you know, really important point, or a really important part of having a purpose-built bus is that we're able to place the batteries underneath the floor in between the two wheel wells. This is important for a couple of different reasons. Number one, I just mentioned that transit buses are run into all the time. So we don't have any batteries in the back of the bus or in the passenger compartments. And the reason for that, again, is because we have a purpose-built vehicle. So we started with a clean sheet of paper, and we were able to put the batteries in the optimal location in terms of safety and performance and weight distribution. And so from a safety perspective, again, you don't have them in common crash zones. It also allows for the lowest center of gravity. When you take a combustion engine platform, so let's say you take a diesel bus or even a natural gas bus or hybrid vehicle, you're limited when you take that existing platform in terms of real estate. So you have to put the batteries on top of the bus, inside the passenger compartment, or in the back of the bus. You know, when you took out the engine, now you have all this space. So having the batteries underneath the floor is really an advantage, again, to safety, performance. Next slide, please. We talked a little bit about this. Next slide, please, just in the interest of time. I'll keep moving. Another part of battery electric bus programs is charging them and infrastructure. And so at Proterra, we offer really a comprehensive solution for our customers. Sometimes I think of the bus as the easy part and the charging and infrastructure as the complicated piece of the puzzle. But we have a great team committed to helping our customers figure this out, whether they be transit agencies, cities, airports, universities. Next slide. And so that team is called Proterra Energy Fleet Solutions. There's two ways to recharge the bus via an overhead inverted pantograph, which is shown on the left-hand side there. And I don't know why we have that picture. We have some better pictures maybe in the appendix. And then also through a plug. So for the overhead charging, we see this both en route to supplement range and also in depot to allow for faster recharging at the end of a bus's route. We follow the SAE standard for overhead charging. We also follow the SAE standard for plug-in charging, which is the J1772 standard. So for both chargers, on the bottom of the screen, you'll see the other OEMs that also comply with the same standard. And as I mentioned in the beginning, standardization in the area of charging, it has been so important for adoption because transit agencies, they have mixed fleets. Airports have mixed fleets. Universities have mixed fleets. So you wouldn't want to buy a charger or invest in infrastructure that only worked with a single manufacturer. And so this has been moving towards these standards has been really exciting for the industry and has helped lead to greater adoption. Next slide, please. So we make three power control systems, 60, 125, and a 500 kW charger. The 60 and 125 are plug-in chargers. And so our sort of middle of the road bus is what's known as our E2. It's probably the most popular bus we sell. It goes about 150 miles. And so that meets most of our customers' routes. That bus would take about 6 hours to recharge on the 60 kW charger, about 3 hours on the 125 kW charger, and we can replenish about 30 miles every 10 minutes with the 500 kW charger. The 500 kW charger is compatible with overhead inverted pantograph. So you can't have a 500 kW plug-in charger, basically because of the vehicle's architecture. Next slide, please. Just a quick note too about our chargers. The green, if you can see color, the green and white box is the power control system. That's what converts the power from AC to DC. And then we have a dispenser, which is the physical interface between the power control system and the bus, you know, just like you might put gas into your car with the dispenser. The PCS, the green and white box, can be located up to 500 feet away from the actual dispenser. So most of our customers have space constraints in their depots or their bus garages. And so it's great that, you know, you don't have to have a large bank of chargers lined up, you know, right there where you plan to recharge your vehicles. We also offer multi-dispenser charging. And so what this enables is basically less hardware to purchase and install. And so both our 60 and 125 kW chargers, for each power control system, you can have up to 4 dispensers. And what this enables is a sequential charge. So it doesn't mean you can plug 2 plugs into one bus and charge, you know, twice as fast. You also can't plug in 2 vehicles at the same time, but you can plug in and charge them at the same time, but you can plug in 2 vehicles and charge them one after the other. And you can also program them to turn on at certain times, you know, if you want to charge when electricity is the cheapest. Next slide. This is basically enabled by one additional piece of equipment, and that's the junction box. So as I mentioned, you could charge up to 4 buses using multi-dispenser chargers off of a single power control system. Next slide. I just wanted to quickly touch on our connected vehicle intelligence system called Apex. This is a both real-time and historical, basically data management system. So customers can see information about both their buses and chargers through the cloud. Next slide, please. And here's where we're headed. So I mentioned that there are several transit agencies, cities, states that have really lofty goals in terms of electrification. And so in this rendering here, this is showing a transit agency that is planning to use overhead inverted pantograph charging. You can see they have all the power control systems lined up sort of in a bank there. All the buses are pulling in nose to tail. The overhead inverted pantograph system is lowering down, quick charging, and the buses are pulling out just like they would today through a fuel island. And so, you know, today we've got deployments 5, 10, even 20 buses. But if you're Houston Metro and you have 1,200 buses you have to charge overnight, that's what we call charging at scale. And so we have an entire team dedicated to helping our customers do charging at scale. We help customers estimate the energy they need, their charging strategy using multi-dispenser charging, and the type of infrastructure they need to the facility in order to you know, charge a full fleet of electric vehicles overnight for the cheapest cost. So this is my last slide. I think I was right around the 20-minute mark. And we might be taking questions at the end, but I see there are some questions in the chat box. So I'll stop talking and see how we want to handle that.
Thank you, Lauren. That's amazing. It's fascinating to see how this industry is being disrupted by companies like Proterra. We are going to take the Q&A at the very end, and there are questions, and we're tracking the questions, and so we'll get to those at the end of this. And so with that said, we'll bring James in. Thank you so much. James Keel from Greenlink in Greenville, South Carolina, who's running a handful of Proterra buses as well. And from what I understand, they're building Proterras there in your community as well.
Great. Can everybody hear me okay? My audio working? Great.
Yep,
awesome.
I hear you fine.
Awesome. So yeah, it is interesting being here in Greenville, South Carolina. A bit of full disclosure, I was in Greenville, North Carolina prior to my time here. So go Pirates, for those of you who are from ECU. But yeah, we do run Proterra buses here in Greenville. So you kind of heard from the manufacturer. I'm going to give you some of the good, the bad, and the ugly from running buses here in Greenville, and kind of what we deal with and see every day. Next slide, please. So what we actually see here are our first 4 buses. We took delivery of these back in April of last year. We run all 4 of them every day. We provide 14 hours of service a day. We're about to start providing 18 hours of service a day. And what we see is we pull a bus out and use it for 7 to 10 hours a day. At that point, the energy is exhausted if we swap it out. So we've kind of got a 2-for-1 replacement right now on diesels. And the thing that's exciting about what Lauren was talking about with the new ZX5 is we have funding to buy more, and I'm looking forward to being able to get a newer product that hopefully is going to be able to deliver even better range and economy for us. But these have just been, it's been a really good experience for us. Next slide, please. So what I'll say is, being here in Greenville, it's awesome to be able to go over to the plant and actually see the bus being built. That was one of, I guess, the most interesting pieces about this. Normally with a bus build, you go to the factory maybe once, but we have the opportunity to go there every week and actually see it coming together. Next slide, please. But I really wanted to talk about, how we ended up here from a finance perspective. As Lauren indicated, the buses are a bit more pricey than what a traditional fuel, be it diesel or CNG, would be. And it did take a little bit of work in order for us to pull that off here. So it has been a long process. I got here in late 2015. And 2016 was very much a working with Proterra, trying to figure out what our options were to get money to buy these buses. So in 2017, we applied for a LONO grant through the FTA. It came through. We ended up with enough funding to buy 2 buses and 2 chargers. We dug around in our pockets and actually managed to find enough federal money through some other opportunities to buy 2 more. So we ended up with 4. Designed them in 2018 and took delivery of April of 2019, and then put them in service in June. Earlier this year, we had another opportunity to go back and apply for more funding. And this is where we started getting creative and understanding really what the FTA is looking for whenever it comes to a grant. So we were awarded $5.3 million in federal funding with $1 million in local to devise 6 more. So we'll be hopefully rolling those out sometime in 2023. The reason for the delay between 2020 and 2023 is not the fault of Proterra. We're in the process of building a new maintenance facility, and we won't install those chargers or deploy them until that facility is completed. But looking at how we ended up with funding, the Michelin Foundation with 10 at the top actually was able to secure us $600,000 in grant money. There was the Greenville Health Authority settlement whenever Prisma Health came into Greenville. They provided us with $300,000. And then Hollingsworth Funds here locally provided $100,000. So we actually ended up with $1 million in local money, non-tax money. So, we went to the FTA and said we have $1 million and none of it's tax money, and it certainly got some attention, and it really, it says several things. One, that the community is serious about having a sustainable transit option, the economic development benefits of it, and really just the vision for Greenville being a green community. But, I see Proterra from really 2 sides of the spectrum. I see it on the public facing side, and I see it on the operation side. And it's always interesting to go and go to conferences and talk to people. And, they get at me aside and it's, well, tell me about your real experience with electric buses. So let's jump to the next slide. And what I would just like to point out that whenever it comes to the actual uptime, so the vehicle being available for service, what you see there is we have an internal goal of 85%. So a vehicle is considered out of service if it's down for preventative maintenance or if there is some other mechanical issue with it. So we've got our gasoline vehicles that are the purple line, our diesel vehicles are the yellow line, and then the Proterra is the green line. So for the most part, our Proterras are actually available for service more often than our diesel buses are. And I think that that's a really important thing to understand and realize here, is that it's a very dependable product, which is kind of getting at what Lauren was talking about as far as having less maintenance to do on it. There are fewer things to break. So it does make keeping the vehicle up easier. Not only that, but Proterra is right around the corner. So if we need a part, we're not waiting on UPS or FedEx. We can actually drive over there the majority of the time and pick it up and bring it over here and put it on the vehicle and get it back into service the next day. So it's just kind of interesting for people to start looking at that data and realizing that that it's a reliable product on the Uptime side. Next slide, please. So wanted to grab a photo from the inside of the vehicle. This was actually whenever it was still at the factory being built, because what we hear a lot of questions about, and we'll get to it here at the next slide, please, is well, what is the passenger experience, right? Because there's two different pools of people that we kind of almost cater to, right? We have the people who use transit, and then we have the people who have an interest in transit, and those two groups aren't always the same. And what I specifically mean by that is, if we go to the people who use the vehicle every day and say, what are you excited to be riding an electric bus around here in Greenville? We hear that it's quieter outside, that on the inside of the bus it's similar, but at the end of the day, our riders don't care. The rider wants to get from point A to point B, and they really don't care how it happens. Now, they've been very happy with new buses. We were replacing some 2002 vehicles whenever these came into the fleet, so they were very happy with the new vehicle. But at the end of the day, from a rider experience, that they care more about where they're going and having a reliable vehicle to get there than what the fuel source is, or at least that has been our experience. So we'll go ahead and jump to the next slide. And this has kind of been what you've heard about in the industry, and we've certainly seen it here. So we do use another technology from the Veracity platform. Proterra has a product as well as their Apex product to be able to get data off the vehicle to understand in more detail how it is performing. But ultimately, we've had this installed since April of this year. It's been interesting to look at what are the biggest factors that affect how the vehicle performs. And ultimately, it really comes down to three big things. One is ambient outdoor temperature. The colder it is, the quicker you are going to use your energy, and that is being spent on heating the inside of the vehicle. We do not have as good of performance whenever it is cold outside as we do when it is warm outside. But Proterra has also been interesting in how they've solved that problem as well. So there's an optional feature that we can turn on that is effectively pre-sequencing. So when the bus is plugged in, you step on the vehicle, the HVAC is running, part of the systems are still running, and it keeps the vehicle at about 72 degrees year round. So that whenever we unplug that vehicle, we're not spending energy waiting for it to heat or cool down, just depending on what time of the year it is. The other factor we deal with is the driver. I can't harp on this enough, in the sense that you have to spend time training your drivers on how to drive an electric vehicle. From it turns the same, the pedals work the same, it's the same as far as, the traditional driving model. The difference is teaching a driver that the accelerator doesn't have just two positions. I have a CDL. I was a bus driver at ECU, and I'm sorry, Wood, but the accelerator had two positions. My foot was off the accelerator or it was on the floor. And the problem, whenever you do that in an electric bus, you can really drain the power down quicker. So teaching the driver how to be more competitive in the sense of having better efficiency, letting the vehicle coast, which is allowing it to regenerate. We'll talk about that here in a minute. And then the third is the terrain. Greenville, South Carolina is an interesting area. Greenville County is very interesting. In the northern part of the county, we're in the mountains. If we go down to the southern part of the county, it's flat for miles. So we do have some interesting terrain, and the routes that we run the Proterras on, you can actually see some different efficiency depending on what route it's on, and it's ultimately because of the grade and the terrain that we put it in. Next slide, please. So wanted to touch on what we can actually see in real time that you're not accustomed to seeing with traditional diesel telematics. So I've got two things here kind of boxed out in red. And this is what was screenshotted in a day earlier this year. But we can actually go back and run historic reports and see this to understand, how much CO2 was being produced by the grid to charge the vehicle, and then how much we've actually saved because we're using an electric vehicle and not because we're using a diesel or a CNG, and understand the net result on that and see how much we are actually saving the environment here in Greenville. The same thing is true. We can look and see how much energy we used and understand our kilowatts per mile in real time, as well as how much has been regenerated. So we'll jump to the next slide. And what we can actually look at here is understanding what it looks like over a period of time. So this right here is Route 510. This was the 9th of September. And what we can see here is our average speed for the day, how much energy we used in service, and what the state of charge was and how much energy it was. So if it was at 100% at the time I took this screenshot, we had expensed 33% that day, and this driver was averaging 1.4 kilowatts per mile. Next slide. The other thing that I'll point out is that, so I've pulled up all 4 vehicles here, and this was actually from April through September. I know it says January. It wasn't installed. It didn't give me a better option to pull the graph out, but we can actually see what our average is as far as our kilowatt hours per mile. So we're averaging about 1.75 kilowatts per mile. It's just interesting to run that for different times of the year, whenever it's cold, whenever it's hot, and see how that fluctuates over time. Next slide, please. The other thing that we can look at that's interesting, and it's even more interesting to look at it on a driver level, is how much energy did we put into the bus versus how much energy we consumed. And you can see that the two graphs are different. And ultimately what this is indicating is that, we put almost 5,000 kilowatt hours into it, but we consumed almost 6,000 kilowatt hours. So we can actually see how much energy we're saving through regeneration, which goes back to driver training, letting the vehicle coast, giving that vehicle an opportunity to get some of its energy back just by how you drive it. Next slide, please. The charge time throughout the day really just depends on how much energy we took out of it. So, if we only used it for 7 hours versus 10 hours, the charge time is going to be greater. So here you can see, basically, we started charging the vehicle around 12:30, which is whenever we traditionally do our change. And by about 8 o'clock, it's expensed. I'm sorry, let me restart over. At 12:30, the vehicle went out. It was completed at the end of its day about 8 o'clock, and then you can see how quickly it recharged. So although Proterra tells you 6 hours, we traditionally have a bus charged in about 4 hours. So we've been very happy with how quickly it can recharge and be available for service later that day or the next day. So let's jump over to the next slide, please. What I've done here is I've pulled our estimated range for the month of September. So this was the 1st through the 15th. And you can see at the beginning of the day what the estimated range is. The great thing about that is we're getting almost 200 miles a day out of the charge. So we say around 180. It's a pretty good average for us. Now, these numbers do move a little bit depending on the time of year. As I was talking about the route that it goes on, what the outdoor temperature is, and really what driver we put on there. But it's nothing for us to be able to put a bus out there and get 10 hours of service out of it on a Saturday without having to bring it in. It'll run the full service day. So it's been better than expected in this case. Next slide, please. So the question is how much have we saved the environment as far as CO2 and as far as NOx is concerned? So a little bit hard to understand the graph here. So this is from April through September, but what you see on the left is going to be your CO2 net result, and what you see on the right is going to be your NOx net result. So we've got almost 25,000 pounds from April through September of CO2, and we've got 125,000 ounces of NOx. So I'm not going to sit here and make that conversion, but it's still a considerable amount of savings that we've seen in that short time. So now let's go to the next slide, and we'll talk about what we've seen on cost to operate. There's a huge disclaimer that I will get into with this, but we can see that with diesel back in December of last year, we were about at 45 cents a mile. September of this year, we're at 29 cents a mile, with electric being about 37 cents a mile. There's a lot of factors that play into these numbers, right? Nobody was expecting there to be a fuel, the bottom to fall out of the fuel prices the way that it did. It's been great for us on a fuel expense savings. But at the same time, it also has why is electric more? You can have a lot of control over your electric rate if you work with your energy provider. For us, that is Duke Power. You need a good relationship moving into this with your energy provider and figuring out when your optimum charge times are. Because of the way we have our service set up right now, and through some other things that we had been doing with the rest of our fleet regarding a midlife overhaul, we had not just been charging at night. We were charging throughout the day, and Duke Energy was charging us a demand charge because that was the way that our contract was written at that time. We've since moved away from that, and we're able to get some better rates by charging at night, which ultimately will make our cost per mile go down. So it's just important to take that into consideration whenever you're looking at those electric rates, figuring out when you're going to be charging, and figuring out when the best time to do that is, and what's going to happen if you don't. And for Duke Energy, 30 minutes or an hour out of that month that you are hitting with a demand is what the rate that they're going to charge you with for the full month. So it's really important to understand and take that into consideration and make sure that your people who are going to be plugging it in are making sure that you have good charger and charger maintenance in the sense of how it is set up and when you're charging. So we'll move on to my last slide, which are my takeaways. And that is, whenever you're looking at an electric vehicle, pick a partner. And what I mean by that is, we have Proterra vehicles. There are others on the market. Realize that it is bleeding edge technology. It's exciting technology, and it's super interesting to watch how it changes over time. But this is not something to go out and do on a whim. You really want to understand who you are going to be doing business with. You want to look at the track record. You want to go talk to people who have the product. The one thing about transit people is we're pretty honest with one another. And it's just extremely important to understand who you want to do business with and finding out what that experience has been like for other people. Pick your utility, partner with them early. The earlier you can let them know what's going on, they may be willing to incentivize you in some ways or help you because you are about to be a huge customer for them. So work with them, find out what they can provide for you. They can be a huge help with this. Work with your manufacturer. Some people do this better than others. Proterra does this better than some people. They will come out and do route studies and figure out what are the best routes to put the vehicle on, finding out what the best deployment option is, tell you what battery capacity you need to buy. It's not something that you just go down to the Ford dealership and take an F-150 home. You need to understand what, oh, my light just went out. Understand what you need in order to deploy it well in your community. Invest in a good warranty. It's extremely important to make sure the product has a good warranty, that the service techs are going to be able there to help you and solve your problems, and invest in good training for those mechanics. It is not a diesel bus. It is different. There's a lot of other training involved with it. It's important to try to get that on the front end. If the bus has been delivered and you're trying to figure out how to operate it, you are behind. You need to get in front of that well early, and then expect a learning curve. It is a different product. It is still a bus, but at the end of the day, it is very different. So it's just important to realize what you're about to embark on, but nonetheless, it will be a good experience. I can't think really anything that has been bad about the Proterra electric bus experience. Were we nervous? Yes. But at the end of the day, it has gotten us a lot of unexpected attention. It's been good attention. People are interested in it. We have people who are more interested in transit now because we have that technology. So I highly recommend it to anybody who wants to get into it. It is something that you have to dive into a little bit, but at the end of the day, we would certainly do it again. We're very happy to have partnered with Proterra. They've been a great vendor to us, and they're good people as well, which for us Southerners really matters. So that wraps up my presentation. My next slide has got my contact information if anybody wants to reach out after this and have more detailed conversation. But at this point, I will turn it back over to Lee if you want to open up Q&A.
All right, James, thank you so much. That was exactly what we were looking for. And thanks to you also, Lauren. This is the perfect compliment, complimentary presentation. We have several questions that we'll get to. I just want to say that, this is the type of programming that we want to provide, our friends and partners and stakeholders in the Southeast and beyond, because these emerging technologies, they're here. And we have friends that have experience with it. We're really excited here in the Boone, Appalachian State community. We're getting ready to get our first electric bus. And I know Craig Hughes with the Apple Cart is, can't wait to see that here, get our first of hopefully many down the road. So we are transitioning to these technologies, and you're the innovators, and you're really paving the way for us to experience from your troubleshooting and your blood, sweat, and tears, literally. So I just really thanks for coming again today. So some of the questions were answered, but there's one that came in for Lauren. I think this was related to your slide. Someone asked, despite it looking like $433 savings over lifetime, was it really $433,000 savings?
Sorry, it's 433,000. So the numbers expressed on the slide left off the zeros.
Yeah.
But that's right. $433,000 per bus versus diesel over the 12-year life. And that assumes 40,000 miles a year, which is the average mileage of a U.S. transit bus.
And then the other question, I think it may have been answered too, can they charge from solar powered sources, or does it have to use the grid and or coal? And I see that, that mock-up of that docking station had a big PV array on top of it. Are there areas that are there charging stations that are integrating solar that you've already seen?
So yes, Foothill Transit, which is actually now, that was an artist's rendering. It's actually in operation now. So we probably need to update that with a real picture. But Foothill Transit in Southern California is using solar. And then there are several other transit agencies across the US who have projects in the works. So the answer to the question is yes. And we love to work on projects like that, because there's always someone who wants to poke a hole in someone doing something good, like launching battery electric buses. And of course someone says like, yeah, but where's the energy coming from on the grid? And of course the transit agency can't control, the electrons coming through the grid. And so in the event that they can use solar, that's exciting and encouraged.
Well, it's still less carbon in the atmosphere, and the grid's getting cleaner every day. So Another question for you, Lauren, is could you talk about Proterra's international sales?
Sure. So beyond the US, we have customers in Canada right now. So we have the Toronto Transit Commission as a customer, and Edmonton in Alberta, Canada. But we don't have sales in beyond the US and Canada right now.
So a question was answered about working with utility for a special rate. Is there any more that you could expand on, James? I know that you stressed that there at the end, how important that is.
I mean, there's a lot that I could talk about, with that. You've got a lot of questions about, can the grid in that area handle the demand you're about to put on it? And that really isn't so much for the power utility necessarily, but sometimes the utility that is already existing on a campus, for instance, upgrades that may need to take place. I mean, we are dealing with a grid issue right now here in Greenville, where we are with our maintenance facility right now. Was installed. We took possession of it in the early 80s, and we've got 240 kilowatt total demand charge up there right now. And we've already talked to Duke, and they've said, well, if you want to add more chargers, you can, but it is not going to be cheap because of the number of upgrades that the utility would have to make and pass part of those costs along to us in order to make it happen. So the earlier you can get ahead of that is great. So in the case of the new facility that we are in the process right now of designing, Duke will be at that table whenever we get to the electrical portion of it with, why don't we go ahead and plan for, 1.2 megawatts, a large amount of power for not only the 10 vehicles that we're going to be having in our possession in 2023, but being able to prepare for what else is coming down the future. So it's just important to take those into consideration.
Great. So kind of along those same lines, this is probably for both of you a little bit. Will the new ZX5 bus, will its range help reduce the need for the fast chargers, for the higher voltage chargers?
Yeah. So we actually introduced our long range platform with the last generation bus, which was the Catalyst. Part of that is we changed battery chemistry. So our first buses were lithium titanate batteries. We were limited to fast charge, about 30-mile range. We moved to lithium ion batteries and were able to introduce higher energy density batteries, put more batteries on. So our Catalyst E2 platform has 440 kilowatt hours of onboard energy storage. We're now able to go up to 660 kilowatt hours of onboard energy storage, which enables about a 300-mile range, with an asterisk and fine print that says it depends on how the driver drives, it depends on the weather, it depends on the configuration, the vehicle weight, which is affected by configuration, etc. And I wanted to add, just if I could, a little bit on special rate cases, and we've seen a lot of really exciting partnerships between utilities and battery electric bus purchasers, whether those be transit agencies or airports. In Michigan, a utility up there has agreed to purchase chargers and pay for installation. We've seen demand charges removed or reduced. Westar Energy in Kansas, which is now Evergy Energy, has committed that any transit agency in their territory using battery electric buses will pay 2 cents a kilowatt hour, no matter when they're charging them. And we've also seen utilities express interest in financing the batteries. So to remove or reduce that upfront delta between the cost of a battery electric bus and a conventionally powered bus. So a utility will pay for the batteries, basically take off that cost from the amount of money a transit agency has to pay, either pay for or finance that. And then at the end of the battery's useful life, let's say it has 80% energy left in it, so it's not optimized for use in transit, but it still has a ton of energy left. Then the utility can use that battery for grid storage or whatever they want to do with it. So that's another more popular way that utilities are becoming involved and really interested in bus electrification projects.
That's really interesting that they're kind of forecasting the end use of these, of the batteries that are going to be in the buses. Probably not quite seeing that happen yet, right? But they know it's going to happen.
Yeah, and not yet, and that's a good thing. So I think I shared that, 2 weeks ago, our first bus went into service 10 years ago. We still haven't replaced the batteries on those buses. So we tell transit agencies expect to replace them at 6 years, just because, we wouldn't want to have an agency, we wouldn't want James to have a surprise like in year 6, like, oh, you have a $200,000 battery replacement you didn't plan for. So
right.
They to plan for 6 years, but the truth of the matter is even our older chemistry is lasting much longer. So you're right, we don't have examples of utilities taking ownership of batteries yet, but in a couple more years, we will.
And that probably helps when operators like James are really training their staff to take it easy on the buses and not have 2 positions, right? So we have another question here. Proterra's power control system, can clients monitor kilowatt hour use in production for each PCS to quickly be able to see when one is producing less than others within a bank or using more kilowatt hours than the others?
I think I understand this question, and the answer is yes. So through our Apex system, our customers can see, what their chargers are doing essentially. And you can control your chargers remotely as well too.
Okay, so the next one is for James, and it kind of combines 2 questions about the use of real-time data to identify any service issues. They want to know, the other one also wants to know more about how Mr. Keel finds useful to compare electric versus diesel buses in the fleet. I saw uptime and emissions, CO2, NOx, and rider appreciation, reliability, and exterior sound. Are there others they find useful as far as metrics are concerned?
Well, I think the term useful is, depends on who you're talking to. I will disclose as much as I can on some things. So I can't discuss who, but there is a prominent tire manufacturer who we are in partnership with right now that is looking at if an electric bus has any difference in the tire wear versus a diesel bus. So, the electric vehicle is a very powerful vehicle. It's got immediate torque, which is something that traditional diesel does not have. So the question is it going to, burn through tire wear faster than a diesel bus does? So those are some other things that we're starting to look at. But I will say the reason that we really haven't gotten into our true cost of ownership is because we're still in the warranty period. We're just now coming off of that. So the real question is what's going to happen whenever we're having to really compare apples to apples with a diesel bus that's no longer in warranty versus an electric bus that's no longer in warranty, and understanding what those costs may be. So, those are some things that we would traditionally look at. The CO2 and the NOx is great depending on audience and who you're going to, and rider appreciation and reliability it really just depends on what the audience is. Aside from that, there really haven't been a whole lot of metrics that we've been asked to provide. I know one thing that we were monitoring closely to begin with was if it was going to affect our on-time performance for the route. Just to find out if there was going to be any difference with how a diesel bus was going to behave on a route versus an electric bus, and we've just determined that there's no difference. So there have been some other things that we've looked at, but we just haven't found them very useful. With our platform, we can actually look at how ambient outdoor temperature affects reliability. But that's just one of those things, once you understand it, it's not something to look at any further. It's just something that you kind of know. So there's not a whole lot of other metrics that we've found like for the long-term useful. We find some interesting facts sometimes, like, oh, that's a cool thing, but not a long-term thing that we want to look at on a monthly basis.
Well, thank you so much. We're up against the hour. James and Lauren, this has just been terrific. I hope everyone was able to get a lot out of us. We really appreciate your time and everything that you do to promote these technologies, and keep on doing the great work out there. It's amazing. We'll stay in touch with you, and we can't wait when we're back on campus and we can bring you to the Appalachian Energy Summit in the summertime in Boone, and have more of these conversations. So thank you so much for coming.
Thanks for the opportunity, and James, thanks for your partnership.
Yeah, we appreciate you. Thank you.
So
since you said you're a Southerner, I'm a Texan. People think I live in California, but I live in Houston. So I just parting words.
Yeah, get that in there.
That's right.
So our upcoming webinars are here on the screen. We hope we can pique your interest. The next one, October the 1st, is in conjunction with Business for Good with Appalachian State University's Walker College of Business. We're going to be talking about corporate sustainability needs a paradigm shift with Dr. Rajat Panwar. And on Thursday, October the 8th, we're going to talk about practical optimization. And this is going to be focusing on machine learning with Travis Smith, who's a principal at Smith Engineering. Be sure to catch that one. And on October the 15th, we're switching gears to focus on local government, where we have Amber Weaver from the city of Asheville. And then the final webinar of this fall series is Thursday, October the 22nd, where we're going to be talking about principles of integrated project delivery with one of the world premier experts, Howard Ashcraft. So thanks for attending today's webinar. We really appreciate your attention, and the Appalachian Energy Summit bids you a great afternoon. Take care.